Well, this is the pyramid of Cheops, built 4,500 years ago. For millennia, it has remained the highest and the largest structure ever built by human beings. Well, shall I give a talk about ancient Egypt? No. I'm not a historian. I would have liked, but this is life. I'm a builder. So, I would like to point out a few revolutions that have marked the way human beings are buildings, since the days of Cheops until the era of drones. What are the common points between the Pyramid of Cheops, the Pont du Gard, built in France in the 1st century AD, the Maya temples, 8th century, and the Gothic cathedrals in the 12th and 13th century? Well, there are many, but in particular, a huge human workforce, a very long construction time, and very little consideration for human rights and the human condition. Then, in the 16th century, a first revolution happens with the birth of a man who will change the face of humanity, Galileo. Why do I speak about Galileo? Because Galileo is not only one of the fathers of astronomy, he is also the first one to develop the strength of materials. So, from Galileo on, builders would no longer rely on empiricism, but on a real knowledge of the physical concepts. A few other revolutions, social revolutions, let's say those of the 18th century. Industrial revolutions, with, for instance, the systematic use of steel since the 19th century. But, well, we could also talk about many things. The large-scale prefabrication of concrete, the fantastic developments of construction machinery, etc. Certificative revolutions. ISO certification, quality control, Eurocodes are essential to guarantee a good quality of the construction materials, the execution processes, and the design processes. Then the next stage, the computer revolution. Not so far away from us. The computer revolution has allowed for us to take full advantage of the scientific advances since Galileo. One example of that is the finite element method, thanks to which we can today produce software able to digitally model and test very complex structures. This would have been impossible almost 35 years ago. The next revolution, it's happening now, the BIM revolution. What's BIM? BIM stands for Building Information Management, and it focuses on the management of building information during its entire life cycle, from the design process to the dismantling. Well, such a rich database allows for all the stakeholders of a construction project, the contractors, the architects, the engineers, everyone, to better coordinate by using a central, unique, and constantly updated source of information. Practically speaking, everybody works on the same 3D model, and each construction element, a column, a beam, a door, is tagged with information such as the color, the price, the construction date, the placement date, the strength, etc. Well, obviously, BIM is necessary to ensure a good quality of the construction processes. But it's not sufficient. Why? Because BIM doesn't avoid the negative impacts of many factors, such as lack of communication between the workers, lack of skilled labor, cost of safety devices, accident, bad weather conditions, etc. So how can we address this? Well, let's get some inspiration from nature. If you look at this swallow, it is building her nest by constantly flying back and forth to transport and assemble mud and twigs into a structure capable of supporting eggs and offspring. Other flying animals use a similar way to build very complex forms, such as bees or those birds from Africa. So why couldn't we do the same? What do I mean? Why couldn't we use flying robots that would assemble many light construction elements, just as bees or birds do? So let's imagine that one or several drones would build this structure and put the bricks next to each other at the very right spot on a completely automated process. This is another example. This is a masonry of about 16 square meters. And we think that it could be built in less than 2 hours with 2 drones for a cost, a labor cost, of 4 euros per square meters. That means 10 times cheaper than a Belgian worker and 5 times faster. Of course, on one hand, this will probably reduce the available work on construction sites. But on the other hand, this will probably also create employment in the robotic sector. So what's the coming revolution, the one we are working on at the UCL? Imagine a BIM model connected to a cloud of drones via a system that would translate the model into drone-compatible instructions. That's what I call robo-numerization of the construction. Don't look in the dictionary. Actually, it's not yet in it, by the way. Of course, such a way of considering building would require us to tackle a few challenges first. The first challenge is to be able to accurately position the drones in space. But this is a problem that already finds solutions today. What you see there on the photo, it's a very nice, fascinating project from Professor D'Andrea from ETH Zurich, who succeeded in assembling a structure with 4 small drones and with hundreds of foam bricks at the very right position. Of course, these positioning problems have to be tested with real construction materials, with big drones carrying big masses on construction sites subjected to wind. This is the drone that we are using for our research at the UCL. It's able to carry masses of 40 kilograms and above. And let me show you this video. It was taken just a few weeks ago, our first tests. You see there the drone, this drone, guided by an operator and assembling a kind of Greek column made out of precast concrete blocks of about 15 to 20 kilograms. And you see that the precision is not too bad. Well, the second challenge is to rethink the construction processes. Why? Not only because of the positioning problems, but because we think that a drone will never be able to carry masses of thousands of kilograms on the construction sites. Even hundreds of kilograms seems to be too much, unless it becomes a heavy and noisy helicopter, and probably dangerous. Therefore, we think that we should limit the masses to 100 or 200 kilograms. Well, currently solutions exist to build big structures with small elements. What you see here on this film, it's 2 workers assembling a whole concrete slab with small and light precast concrete elements. Actually, it's a construction process which is not often used because it is slow. But If 2 workers can do it, 2 drones can do it, and much faster. So, you have seen that many changes in the way we are building since the pyramid of Cheops, and probably that many other changes will come with the coming of robots. On our everyday life, robots should make the world safer and more comfortable. Let's hope it. On construction sites, they should help us to build more efficiently, faster, and yes, with a better profitability. But at the beginning of this talk, I was speaking about a few common points between old monuments. Do you remember? One of them was no consideration about human rights and the human condition. So my greatest wish is that this coming revolution, the coming of robots, will raise the standard of living of everyone. I thank you for your attention.